So, good evening guys, welcome to NEET World of Physics class. So, in this class we are going to deal with work, energy and power. This is the second class of work, energy and power. Okay. So, in the previous class we have started with the lesson work, energy, power, and we have seen what is work and the formulas of work and the SI unit of work and what is the different cases of work, like when the angles are 0, like F force and displacement, the angle between them is 0, 180, 90. Okay. Now, we will do a problem on that now. Okay. Find the angle between the force and a displacement. That is, force is given as 3i plus 4j minus 5k, whereas displacement is given as 5i plus 4j plus 3k. Also find the projection of F on D. Okay. So, the first thing what we will do, we will find the angle between them. Okay. So, first we know that work done is equals to F dot D, force and displacement, or else the other formula FD cos theta. This one we know. So, we don't know that work done right now. We know that force and displacement has been given. From this formula and given things, I need to find the angle between them. Right now, can I write like this? Equation number 1, this one, and this is equation number 2. Both are equal only now. Work done F dot D or FD cos theta. So, can I write F dot D will be equals to FD cos theta? Right? No? Same. Now, if I want to find what is F dot D, can I write like this? F dot D will be equals to 3i plus 4j minus 5k dot 5i plus 4j plus 3k. Right? No? Now, I need to do the dot product of both of them. So, if I want to do the dot product, we know the condition that I dot I will be equals to 1, j dot j will be equals to 1, k dot k will be equals to 1, whereas I dot j will be equals to 0, right? No, because when I talk about the angle between them, it is 0 degree, right? No, cos 0 is 1. When I talk the angle between them is 90 degree, I and j, like x axis and y axis. What is the angle between them? It is 90 degree, right? So, when I talk about 90 degree, cos 90 is 0, right? No. So, similarly j dot k and k dot I also 0. So, directly we can apply that 3i and 5i. So, 3 into 5 is 15, 4 into 4 is 16 plus 16, 5 minus 5 into 3 is minus 15, right? No. So, 15 and minus 15 get cancelled off. So, I can say it is 16, right? No. Now, I need to find what is F separately and what is D separately, which means this is in vector form. I need only the magnitude, right? No. If I talk about magnitude, like F will be equals to under root of 3 square plus 4 square plus minus 5 the whole square, right? No. So, how much I will get? Root over 3 3s are 9 plus 4 square is 16 plus 25, right? Now, so 9 and 16, 25, 25, 25, 50. So, root 50, right? Now, what about the next one? 5i, 4j, 3k. So, similarly, D will be equals to under root of 525 plus 16 plus 9 will be equals to same 50, right? Now, I will write the answer for F dot D. F dot D is 16 should be equals to root 50 into root 50 cos theta. So, root 50 into root 50, 50 will come. Yes, no. So, 16 by 50 is equals to cos theta. So, this is 4 times, or let me take this as 8 and this is 25. Yes, no. So, cos theta will be equals to 8 by 25. So, theta will be equals to cos inverse of 8 by 25. If the answer is option is given much simplification, I can do the simplification. Okay, up to this clear now how to find it the angle when only force and displacement is given. Okay, take note. Hello Sohail, hello. Yes, 8/25. Copy down fast. So once you have completed, let me know. We'll go for the next part of the question. Also find the projection of F on D. We should find it now. We'll go for the next one. Okay, so okay, so listen, now I need to find the projection of F on D right now. So same formula, F is equals to F dot D, W is equals to F dot D and W is equals to F D cos theta right now. So I can equate that, F dot D equals to F D cos theta. I need only projection, right? Projection in the sense like F and cos theta keep one side and remaining term other side, which means F cos theta will be equals to F dot D by D right now. So what will be the answer now? We know that F dot D, how much we got? 16 we got. So 16 by root 50, that's it. So if they are asking what is the projection of D on F, so D cos theta should be equals to F dot D by F. Okay, so same answer, because when I take this magnitude of both of them, I will get the same answer. Okay, take it. Done? Okay. So the next question is, yeah, so this is the answers. So 16 unit root 15 root 50, and we got 16 by 50, no. So they have given the much simplification. We have stopped up to 5 by 8 in that set. Sorry, 8 by 25. Yeah. So theta will be equals to cos inverse of 8 by 25. The next one is, yeah, projection of f on d. The same thing we got 16 by root 50. Okay. So the next question is, a cyclist come to a skidding stop in 10 meter. During this process, the force on the cycle due to the road is 200 Newton. One they have given, the displacement is given, one is force is given, and is directly opposed to the motion, which is nothing but a person is going in a cycle, okay, 10 meter he have going, okay, and what is the thing they are saying? A 200 Newton force is opposed him, which means he is going in this direction, force is acting in this direction, right? No. So force and this is displacement, angle between them is 180 degree. This is theta, so theta will be equals to 180 degree. How much work does the road on the cycle? How much work does the road on the cycle? Second part is, how much work does the cycle on the road? Okay, two cases, two different types. One is, how much work does the road on the cycle, road on the cycle, cycle on the road. Both are different because they have told, no, the force on the cycle due to road is 200. Okay, so first one we can find the same thing I can use. So work done will be equals to F dot D, which is nothing but FD cos theta, whereas this is for the first part of the question. Okay, force is how much? 200. Displacement is 10 meter. So 200 into 10, cos 180 is minus 1. That's it. Minus 1. So minus 2000 joules. Okay. Next one, how much work does the cycle on the road? Can you give answer for this one? We'll see. You take this part of the first question and give the answer for the second question. Try it now. 2000 you are getting. We'll see the answer. So 2000 in the sense like cycle on the road, road on the cycle, both are same.
Cycle should overcome that 2000 Newton force.
Should be overcome.
So more
Okay,
than 2000.
we'll check it. Okay, so listen. So first question, first part of the question. The stopping force and the displacement makes an angle 180 degree. That one we have cleared with each other. So work done will be minus 2000 joules. Now the second question, there are two forces acting on the road. One is weight of the cycle. Right now, weight of the cycle is mg. Cyclist, like cycle acts 200 Newton force on the road from Newton's third law. Opposing, like one force is opposing me, another forcing, I am going in opposite direction, right now. So I am going with one force, opposing force is my 200 Newton, which means I am going with 200 Newton. But the road undergoes zero displacement due to any of these forces, right? No? Yes or no? So angle between them was 0, and this one 200, opposing force 200. Any of this force will be, displacement will be 0, so work done will be 0. Got it? You have done that one second part, first part you left it. Yes, no?
So first one is also 0 because MG is perpendicular to the.
Yes. That's why the road undergoes zero displacement due to any of these forces. Can you go for the next one?
Yes.
Okay. So next topic is kinetic energy. Before that, what is energy? The topic energy. It is nothing but capacity to do work. Yes, no? If you want to do something, you need some energy, no? In midnight, 2 o'clock, if I wake you up, go and read something or go and lift something, will you able to do? No. You need some energy, right? You need to be fresh enough to do something, right? No. So it is capacity to do work. Okay. So the energy is nothing but capacity to do work. Okay. And what is the SI unit? Whatever SI unit we have seen in work now, joules, the same SI unit only for energy also. Okay. For example, in basic classes we have studied potential energy, kinetic energy formulas, right? No. Yeah, same formula of mv square. I will take that formula of mv square. Okay, let us derive whether it is same or not. Mass kg, right? No. Kg meter per second the whole square, no. So kg meter square per second square. Am I getting the same? Yes, I am getting the same. Kg meter per second square was the SI unit of force. Force into displacement, no, displacement meter. So kg meter square per second square. It is joules. So same, it's also joules. Okay. SI unit is joules. Now kinetic energy. And energy is classified into many types. We are discussing about two types only in this chapter. One is potential, one is kinetic. The first one is energy possessed by an object by virtue of its motion. When object is in motion, no, we will talk about the kinetic energy. Okay. Potential energy is nothing but I am storing some energy. If you want to beat someone, okay, you will store some energy. You will take your hand long back. If you beat like this, will he able to feel that pain? No. If you take your hand back and if you beat, what happens? He will feel pain. Right now, you are storing some energy and you are releasing. Right now. So, potential energy is nothing but storing energy, we will say, and kinetic energy is nothing but it's a energy in motion. Okay. And the formula is of mv square and it's a scalar quantity. So SI unit is joules. Dimensional formula is ml square t power minus 2. Okay. Take it. Okay. We'll complete it. We'll go for the next one. Okay. So the next one is, yeah. In a ballistic demonstration, a police officer fires a bullet of mass 50 gram. Okay. With a speed of 200 meter per second on a soft plywood of thickness 2 centimeter. The bullet emerged with only 10% of its initial kinetic energy. Got the point? They have not mentioned the final final velocity. Initially they have mentioned the velocity, it is 200 meter per second, and the second point what they have told us, the bullet emerged with only 10% of its initial kinetic energy, which means final kinetic energy will be equals to 10% of his 10% of kinetic energy initial, that's it. Right now, that's the point. What is the emergent speed of the bullet now? What is the final velocity they are asking? Emergent speed they are asking. So first let me find that kinetic energy initial will be equals to of m v initial square. Okay. What is the mass they have given? 50 gram. Convert to kg. Right now.
10 to the power minus 3.
50 into?
10 to the power minus
Okay. So 50 into 10 power minus 3 into 200 square, right? No, 200 square. This is my initial kinetic energy. What about the final kinetic energy? Final kinetic energy will be equals to 10%. No, yes, no, 10%. So 10 by 100 into
10.
how 10? I need to substitute this value there. That's it. Okay. This value only you are getting 10. Okay. Give the answer now. I need the final velocity. Done?
Under root 40.
Okay, you are getting under root 40. Okay, fine. Now we'll do it.
20 meters per second.
Okay, no issues. 20 meter per second you are getting. Right now? Okay. So let me find now. So kinetic energy initial I need to get it. So of into how much? 50 into 10 power minus 3 into 200 into 200. Right now? So what I will get here? This 3 zeros and now 2 0 and this 1 0 will get cancelled off, no? And this 1 and this 2 and this 2 will get cancelled off, no? Right, no? So 5 into 2 is 10, 0 0 I should add, it is 1000 joules. Okay. Now what is the thing? I need to find that 10% of kinetic energy initial. Okay, now you get it. You told it is 10 you are coming, no, it is 1000 joules. Now you get it. Then we'll see. So kinetic energy final will be equals to 10 by 100 into kinetic energy initial how much? 1000, no? So 1000. So this two zeros and this 20 will get cancelled off. So it is 100 joules. Now I need to find the final velocities. That's the thing. So of m final square, velocity square should be equals to 100. So will be equals to 100 into 2 by 50 into 10 power minus 3. Okay. So this one, this is 1 times and this 2 times I'll say. Okay. So 2 to 4, no? 4 into 10 power 3, which is nothing but 4000. Okay. So final velocity will be equals to under root of 4000. That's it. Then known.
So here no need of that plywood.
Which one, sir?
Force.
Nothing. Like simply they have mentioned that this is the plywood. They have given the bullet with initial velocity 200 meter per second, and bullet emerged only 10% of its initial kinetic energy. Emerge in the sense only 10% it has been went inside. Other part of the question how they will ask, no, the bullet has been went inside fully and it has been stopped. That's the one of the type question. That one we have seen. So this is another type of the question. Okay, only 10% of the initial kinetic energy went inside. Okay. Suppose if they mention that 50% of the kinetic energy
Is left.
which means
Emerges.
50 by 100 into kinetic energy initial. Okay. Done? Fine. So next one, this is the answer. You can check it. 1000 joules, and it is 100 we got, no? Final kinetic energy 100, and the second part it is like so final kinetic energy, so velocity. Okay, they have calculated 63.2. We have stopped up to root 4000. That's it. Okay, that's it. Next one is work energy theorem. So work energy theorem speaks about the change in kinetic energy of a particle is equal to work done on it by any net force. Okay, like how they are saying is initially some kinetic energy is there and final kinetic energy is there, which is like a change in kinetic energy is said to be work done, which is if I take this equation to prove that if I multiply 1 by 2 m on both the side, what will happen? 1 by 2 m v square minus 1 by 2 m u square equals to 1 by 2 into 2 a s into m. Right now 2 will get cancelled, mass into acceleration is force, no? So force into displacement is work done, no? So half mv square, it is final kinetic energy, no? Half mu square, it is initial kinetic energy, no? So it is work done. So work done is nothing but change in kinetic energy. Okay, take down. No, like you can, if you want, you can take the derivations, and the main formula is this one. Okay. Done? Okay. Here is the question. I'll give it as a homework question. Okay. It is well known that a raindrop falls under the influence of the downward gravitational force. Yes, no? Clouds are there. If it becomes water, what will happen? It will try to come down only, no? It is due to gravitation, we know, right? No. And opposing resistive force. The latter is known to be proportional to the speed of a drop, but it is otherwise undetermined. Okay. Consider a drop of mass is 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. First question, what is the work done by the gravitational force? Okay. And what is the work done by the unknown resistive force? Okay. These are the two part of the question. So you should take this question and complete it before the next class starts. Okay, this is the homework question. You can take the question. So with this we'll end the session. Okay, we'll start with the next class with the question and we'll go for the next topic. Okay, no? Okay, we'll wind up now. Thank you guys.
So K initial is 0.